Hi there, how you doing? In this video series, I'm going to be going over the past software design and development exam 2018, for the year 2018. So I'm going to step by step every question and I'm going to explain each one. In this particular video, we're going to be looking at multiple choice questions 1 to 10. So let's get right into it. So, yeah, let's just get right into it. So, general strategy to answering multiple choice is going to be you're going to get, with multiple choice, you get 4 options, and then basically you have to choose the most correct answer. So there might be a few answers that are reasonable sounding, but you have to choose the most correct. So basically, I'm going to do a few questions and I can show you the strategy to answering them. Okay. So, question 1. Consider the following code fragment. Begin x equals 5, y equals 8, x equals y, y equals x, print x, y, and what output is produced. So this is a pretty straightforward question. There's no this is kind of just a warm-up question just to get you used to what's going on. It's never a bad idea to always do something called a desk check in these kind of algorithm questions, even though this is really simple. So if you ever get confused, just do a simple desk check. And what I mean by this is just draw out the variables. Draw out the variables into a table and just write line by line what they are. So x equals 5, y equals 8, okay, x equals y, so x equals y, which is 8, so that's 8, y equals x, and x equals 8, so that equals 8 as well. And then it says print xy, so we know x and y are 8 and 8, so the answer is obviously D. So not a lot of confusion there. You just have to write it out. Don't if you're confused and you're not quite sure, always just do a desk check so you know what it is, as opposed to trying to maybe do it all in your head. I see some students try to do everything in their head, and for a simple question like this, you can get away with it. But when the algorithms become more complicated, you might mess up. So it's better to just double check with a desk check. But the answer is 8, 8. Yeah. So I don't really have to. Generally, I look at what the other options are, but it's generally it's kind of straightforward why the answer would be 8, 8 here. There's nothing really to trick you. I think B is oh, if you just thought 5 and 8, x was 5 and y was 8, but it's just basic code that if you set something to another variable, then it sets it to whatever value it was. So in this case, y was 8, so x becomes 8. So yeah, pretty straightforward. We'll move on. Question 2. So an algorithm has been developed to check temperature. Too cold is displayed if the temperature is below 40 degrees, and too hot is displayed if it is 60 degrees or more. Otherwise, the display is just right. The algorithm has been tested with the values 30, 50, 60, and 70. What other value should definitely be tested? Right, so this might seem like a mouthful of a question, and whenever you see something like this long paragraph here, and you're kind of reading it and you're kind of maybe panicking a bit, basically just break it down line by line. Okay, so for example, you can go, I sometimes look, okay, what are we actually looking for? We're looking for a value, and it's like test data, right? So the topic is test data, and it's what would be a good value for test data out of all these options? So going line by line, so we're checking temperature. So too cold is displayed if the temperature is below 40 degrees. So what I would do is just on a spare piece of paper or in your head if you want, just write out less than 40 is too cold. So just write less than 40. And too hot is displayed if it's 60 degrees or more. So less than or equal to 60. So basically I'm just translating these to like the condition statements, right? So these are conditions. So if it's less than 40, it would be too cold. If it's greater than or equal to 60, it is too hot. Otherwise, the display is just right. So between these two values would be just right. So we've already tested 30, 50, 60, and 70. So when you look at these two statements, when you think of when you're testing condition statements, you need three values. So the first value is you need less than whatever condition you're looking at. You need the same value, and then you need the greater value. So 3. So less, the same, and greater. So for example, for the 60, the too hot, we need the value 60. We need something that's less than 60, say 50, and then we need something greater than 60. In this case, we could put 70 as an example. And as you can see here, these values have already been tested, as said in the question. So we've got something that's less than 60, which is 50. We've got something that's greater than 60, which is 70. And we've got 60 itself, which is the condition, the value condition. So that's good. So let's look at 40. So if we've got something less than 40, yeah, we got 30. So 30 is less than 40. Have we got something greater than 40? Yeah, we've got 50, 60, and 70, so that's fine. But do we have 40 itself? No. And as we can see in the answers here, one of the options is 40. So in this case, the answer for the value that should definitely be tested is 40, which is for the too cold. So the reason we test these is, I believe we call them boundary conditions. So we're testing boundaries because that's where potential errors could emerge if we've got the boundary conditions wrong. So one of them happens to be less than 40. So yeah, there's nothing really else I can say on that question. You just got to break it down bit by bit, translate it. You have to translate these into kind of condition statements, and then we can test the boundary by testing less than, greater than, and the same as the value. So yeah. So one strategy for multiple choice is, if you're confused, investigate the other options. So you might have a suspicion of what is definitely correct, but it's always worth looking at the others. So in this case, C is what we suspect, but let's look at the others. So 80 is obviously not it because we've already got 70. So 80 would be a redundant test value. 20, we've already got 30, so 20 would be a redundant test value. Now 0, you might think, oh, 0 is like a weird kind of special value, right? So it'd be worth testing 0, shouldn't it? So 0 is an interesting value, but in this case, it's still like less than 40. Like, unless you're testing, like trying to test like some negative number maybe, but because like 0 is the boundary between positive and negative numbers, but it's not the boundary that we're interested in. We're interested in the 40. So in this case, 40 is definitely the correct answer, and 0 would just be redundant because we've already tested something less than 40, which was 30. So, yep. All right, let's proceed. So consider the following code fragment: get R, get T, Y equals R over T. Which combination of inputs for R and T will cause a runtime error when the code is executed? All right. So here are options. Now, so there's a few parts to this question. If you're a wizard at maths and you really like maths, you might be able to pick up the answer automatically, because you see here we have a division. So this is a division operation happening here, and we know from maths that there's an error called division by zero. Division by zero. Which is an error because you can't divide by zero. The result is like infinity or something. So it's the type of error. Now, and then based off that, you could be, well, so that means that t needs to equal 0, and that would cause an error. And in this case, we just have to look like, this is the only time when t is 0, so the answer is B. So it's kind of straightforward, but what I'm going to take a little bit more time is, so I don't know if you actually know what a runtime error is. You might just, so the other thing is, with multiple choice, you might just go in and go, error, there's a division, it's probably 0, it's probably that. But be careful, because sometimes you want to actually understand what all the parts of the question are asking you, like what is a runtime error. So in fact, this is probably a good time to look at and understand all types of errors, just to know exactly, whenever you see runtime error, you know what's going on. So there's 3 types of errors in this course. There's logic, there's syntax, and then there's runtime. So the easy one that most students understand is a syntax error, which basically means before you execute your program, there's something wrong in your actual code. So the interpreter or compiler will actually will tell you that, hey, you forgot that colon, or you forgot that semicolon, you didn't close that bracket. So that's a syntax error, and that happens before execution of the program. The next in line is the runtime error, which is an error that happens while the program is running. So for example, you could have a loop, you're looping through an array or a list, and oops, you accidentally go out of bounds in that list or array, and that will throw you a runtime error, so an error that will happen during the execution of the program, and it'll crash your program. So that's the runtime. So runtime is during the execution of the program. And finally, we have the logic error, which is after the program has executed and the output is not what we expected. So that's after. So it's before, it's during, and then it's after. So just a good refresher for errors. But in this case, yeah, the inputs that would cause an error would be 4 over 0. Anything that divides by 0 is an error. Don't be careful, because you might think, is it division by 0 or is it 0 divided by something? Know that 0 divided by whatever, like 0 divided by 1, just results in 0. It's the whatever divided by 0 which equals error, like infinity or something, because it's impossible to divide by 0. Because yeah. So yeah, because like with fractions, it's like if you have like a half, the denominator basically references how many parts there are. So in a half, there's 2 parts. So 2 over 2 would be 1, because that's the whole. So there's 2 parts, right? Or if you had like 3/4, that means it's 4 parts. The denominator is the part, how many parts total that you can have. But if 0 is the denominator, then it's like it's an infinite number of parts. There's no there's no number up here you can put which will satisfy a 0. Because you're like splitting things up into little parts or pieces. That's how I'd think of it. And a 0 is just infinite number of pieces, so it's impossible. So anyway, moving on. Which of the following is a part of software maintenance? Have a look at the answers here and have a think. The key part of this question is remembering the most correct answer. So I'm going to go ahead and look at all of these because it's kind of tricky. So A, defragmenting data files on a regular basis. So defragmenting data files could be considered a type of maintenance task. So it could be considered maintenance. But it's in terms of software maintenance, it's a maintenance, but in terms of software maintenance, it's kind of not really, because like if you've ever defragged data files, it's like in Windows, you basically open up a program in Windows that defrags it for you. It has to do with the operating system. It doesn't really have to do with you going in and doing some code to update. It's not like a programmer going in to modify a program, like to do some programming to fix like updated requirements for the problem for the program. So it's a type of maintenance, but it's not quite software maintenance. And if you don't know what defragging is, it's basically so there's like a certain amount of memory in a computer. This is the really simple version. There's basically memory in a computer, and when you store photos, files, or you run programs, the operating system allocates you memory. It just allocates you memory in these spots in memory. But the problem is that as a user, the program doesn't know what is going to be stored and when it needs it, and so the problem occurs when a user starts deleting things and moving files around. So then basically what happens is you have this block of memory, say, and this is just an abstract version of the memory in your computer, be it a hard drive or RAM or whatever, and you have all these like memory used up. Say this was your memory, but when you start deleting stuff, you actually start getting gaps. So you might have some allocated memory here, you might have some here, you might have some here, but you start to get these gaps, and these gaps become so small that you can't actually put any other files there because it's so small, and you start getting these little these little empty spaces everywhere. Because files don't come in like a set size, they come in all different sizes. So you start getting these like tiny small gaps that you can't fit anything into. And basically what defragging does is that it attempts to remove all these empty spaces and compact everything into just one space to free up memory in the computer. So just a little diversion, just so you know what's going on. But basically you can guess from this that it's a maintenance task. It's not strictly software. But if we look at B, modifying code in response to change requirements, this is kind of like the big green light because it's like modifying code, so that's software, in response to changed requirements. So that's kind of maintenance because the problem has changed and we want to update our software to meet the new changed requirements. So this is kind of like, as soon as you see modifying code, it's kind of like a big green light for you. So B is the correct answer. But let's look at the others. Ensuring that software is compatible with a range of hardware. So this sounds like the kind of initial implementation of the software. So it's not necessarily ongoing maintenance. It's just like the initial thing is that you want to make sure that your software can work with the hardware that it's going to be on, that it's going to run on, right? if this question was instead ensuring that software is compatible with new hardware that was introduced, or there's the company has brought in you some new hardware and they want to make your software run on it, then that would be software maintenance. But in this case, this isn't really maintenance. This is more like the initial implementation of the software, like just making sure that it works. So D, making sure all personnel are trained in the use of any upgraded software. This is like maintenance, I guess, but it's more like maintenance of your staff. It's not really to do with software. Like, it involves, it has the word software in it, but you're not actually maintaining software, you're maintaining people. So it's not really like software maintenance, but it is a maintenance task. So out of all these, some of them are maintenance, but the most correct is B. So how is a code of conduct relevant to software developers? So I'm not going to read all these out because I'm going to lose my voice, but basically just have a read of these. So if you don't know what a code of conduct is, anyone who's had like a kind of a formal job, like if you've had a part-time job at like Woolies or Coles or wherever, retail, hospitality, there's probably somewhere in like your onboarding you would have heard the word code of conduct. But even if you've never had that, if you just break down this word like conduct, like what is conduct? What is the meaning of conduct? How I conduct myself? It basically relates to behavior. So conduct, like almost a synonym for the conduct, how you conduct yourself, would be like behavior. So right away you can probably think, oh, B's probably correct. But a code of conduct is basically a set of rules of how you conduct yourself in a workplace, for example, such as how you dress, how you speak to customers or clients, so on and so forth. So in this case, it's B. Rate of pay is more to do with like your employment contract. It also has to maybe do with minimum, like minimum wage, but it's not really code of conduct. Describes various duties included in the role. That's more like a job description, so that's not code of conduct. Minimum conditions for them to be allowed to work. Once more is like employment conditions, minimum employment conditions. It's not really like code of conduct. So yes, the answer is B. Which type of software is not protected by copyright law? Okay, so once again, you just kind of need to know your copyright law. So shareware is basically where you share like a free trial. You share some software as a free trial with the intention that the person who uses it will go on to pay. So you share the software, the free trial, and then people use the free trial, and then there's the intention to go on to buy the actual product, like the paid version. So, and this has a copyright license, so it's not shareware. Open source, you might think, well, first of all, what open source is basically, it means anyone can view the actual source code of the program to see how it works. But just because you can see the source code doesn't mean you can just take it and claim it's your own. So it actually is under copyright, so it's not B. Public domain is basically, it's the domain of the public. So public domain doesn't have copyright. So you can take something from the public domain and use it in your own work or product or project, and you don't have to worry about attributing copyright. You could always say where you got it from, but you don't need to say like it's not under law, copyright law. So the answer is C. Creative Commons is actually a type of copyright license. So yeah, so obviously that would be protected by copyright law. So the answer would be public domain. Alright, number 7. If locked equals true, then increment choice and if. What is the most appropriate data types for locked and increment? Locked and choice. So locked equals true, so the only thing that can be true or false is a boolean, so locked kind of obviously has to be a boolean. So it's either, so based off that we can eliminate C and D, so it's A or B. Choice, increment choice basically means you're dealing with an integer because you're incrementing by 1. So increment, for people who don't understand what increment means, it's basically choice equals choice plus 1. So you just add 1 to it. So basically it can't be a string because you can't add 1 to strings. So it has to be an integer, so the answer is A. Be careful, if there was like little quotations around this true, then it might be that locked is a string, but there's no quotations, it just says it's true and it's also capitalized, so it means it has to be a boolean. So in this case it has to be A, because choice can't be a string. So yeah. Alright, number 8. So consider the following diagram of a system. What information does the diagram provide about the system? So the first things first, when you see this, it doesn't actually tell you what type of diagram it is. Oh, yeah. It doesn't tell you what type of diagram this is. And basically your best way to know the answer to this question is identifying what type of diagram this is. If you can do that, you pretty much know the answer. So for those who don't know, if you look at it, it's like, it's got these boxes, it's got these arrows that are flowing kind of everywhere, and it's got these circles, and it's got this kind of half-open box. It's kind of, this kind of look is very unique, and it's basically it's a data flow diagram. I don't think there's any other diagram that looks similar. So remember the IPO diagram just has like 3 boxes, which represents the input, the process, and the output. So it's definitely not an IPO diagram. A structure chart has like the central node, and then it kind of branches down into like little submodules. So it has the central node, and it works its way down, and you go like left to right, and you go up, and then left, and then up. And then you can have like a diamond as well for decisions. So it's definitely not a structure chart. And it's not like a railroad diagram or anything. So it's kind of obviously a data flow diagram. There's also a context diagram. Yeah, there's also a context diagram, but the context diagram is actually a little bit more simple. It's usually very specific, but when you see all these arrows kind of going everywhere, like up, down, left, right, it's obvious. It's a data flow diagram. There's no other possibility here. So anyway, once you see that it's a data flow diagram, you can basically know that it's the flow of data. That's basically what a data flow diagram shows you. So if you look at all the options here, you think, okay, what is the flow of data? And you can see B, the movement of data between entities and processes. So it's basically that. You look at the others, the the links between different types of modules. It's not really what a data flow diagram would do. So it's not that. I mean, it kind of shows, it kind of has different, you could call these different modules, I guess, but it's not really that correct, so it's not really A. C, the connection navigation between different user interfaces, that is for a storyboard. Like you have a storyboard showing all the different interface elements, so that's more for a storyboard, that's not for a data flow diagram. The relationship between software and hardware components. So if you remember the data flow diagram, there's this symbol here which represents a data store. And that could maybe be considered a like a hardware component. So on one side it might show some hardware components, but really, as I said, the most correct answer is it's a data flow diagram and it's supposed to show the movement of data. So it can show some software and hardware components, but the most correct here would be B. Yeah. It's obviously not it's obviously not a system flow chart either, because a system flow chart starts at the top and goes down. So you can go through like think about all the diagrams that you know and then try and eliminate each one. So yeah. So also a quiz, like you gotta remember that this is the these are the entities and these are the processes, or this is the rectangles are the input outputs. Like for example, you could have customer. You could have customer, that could be the customer, and this could be the process, so like, I don't know, scan, like ticket scanner, for example, and then the receipt is passed on to a customer or what have you, so you could have different ideas. And then this would be like, I don't know, a data store, so it could be like, I don't know, just like journal storage or something. It could be anything, any kind of storage. So, yeah. All right. Number 9. Which row of the table best matches a screen element with the data being entered? So, basically, you just need to know your interface elements. Like most students, you don't even need to really most students know are familiar with the web, and how to navigate through interfaces. So a lot of this is fairly straightforward. So let's just eliminate it. So text boxes, a signature. So signature is like an image. So an image can't fit in a text box, so it's not A. B, check boxes, your date of birth. So a date of birth is like either you enter it into a text box or you have like a drop-down menu, like a calendar. Check boxes don't really fit. It just doesn't. You can't put in a unique. So there's 365 days of the year. So it'd be kind of. You'd have to have a lot of check boxes in order for you to put your date of birth. You'd have to have 12 for the month. You'd have to have the past I don't know 200 years for the year, and so it just become way too untenable to do it with. It's been in kind of way too much time to do check boxes, so it's not check boxes. Drop down list, the name of your first pet. So a drop down list. So this would be good for. This would also be you'd need a text box, a drop down list. The potential names for a pet are like millions, so it's like a drop-down list is just not the way to go. Like you'd have to have like a huge drop-down list, and it'd be unfeasible. So that obviously D, radio buttons, your favorite day of the week. Yep, so radio buttons for this favorite day of the week because there's only 7 days of the week, so radio buttons would be good because also it says only one. So radio buttons only allow you to pick one. So since it's only asking you for one option, D would be the answer here. Alright, number 10. A programmer can make use of stubs to... So you basically got to know what a stub is. So a stub is basically it's a function or a module that hasn't been coded yet, and it's simply a placeholder so we can run the main line of the program, and then we can fill it in later when we need it. So it's just a placeholder, just so it allows us to run the main program, and then we can fill it out later. So you could have a function that just says like print like hello, and that's all it does, and then you fill it out later. So based off that definition, reuse previously written and tested modules. So the purpose of it isn't to reuse previously written code. It's supposed to be an empty like functional module, so it's not a. Help clarify the operation of the software to the user. That's like user documentation, and stubs have nothing to do with the user, so get rid of that. Improve the performance of the code by removing unnecessary detail. That's optimization, and that's not what stubs are designed for. Test the logic of the main line without having to fully code all the modules. To check, so it's D. So you might, students might get confused by maybe it's A, but I honestly feel D is obviously definitely the most correct, because A is like you're not reusing previously written code. It's kind of not a fully coded module, so it's definitely D. So, all right. That's the first 10 questions. In the next video, I'll do the next 10 questions. But for now, I'll leave it there. See you guys. Also, if you're interested, you can check out my website in the description down below if you're interested in private tutoring from me. So, in software design and development. So, cool. Alright guys, see you later.